So we're going to look at descriptive statistics, learn how to calculate the measures of central tendency and dispersion. But before I go into the calculations, I would want to start with the theoretical part. So you've heard of qualitative data and quantitative data. In your own terms, what is the difference between quantitative data and qualitative data? What do you think is the difference between qualitative and quantitative data? Anyone?
With qualitative, it's something that you can't measure, but quantitative is measurable. It can be numerical. The qualitative is theoretical.
Okay, that's good. So we're discussing quantitative and qualitative. These are two primary types of data that we use in research analysis. So quantitative in nature looks at numerical measurements. What is measurable? Okay, so quantitative, we measure it, and it involves expressing our figures in numbers. So the main purpose of quantitative data is basically to quantify relationships, the patterns, the trends, and also to allow statisticians to make statistical analysis. So usually we collect this using instruments like surveys, questionnaires, etc. So this is quantitative data. Then we also have qualitative data. As she explained, this is data that is what? Non-numeric. So qualitative looks at the quality of the information. So qualitative data is mainly descriptive in nature and looks at qualities and characteristics and attributes. Its main aim is to gain an in-depth understanding of a phenomenon. By the way, this course basically mainly teaches you to do research. So those of you who will be doing your research, that's predominantly what I do. I'm a researcher, so you need to really understand this very well. And we collect this data using interviews, focus groups, case studies, open-ended questions, allowing the researcher to get a more detailed view. Now, what are some of the examples of qualitative data? What are some of the examples of quantitative data? So like we said, quantitative is quantifiable. And so we look at measures of height, temperature, number of students in this class, the scores you get in an exam, whereas qualitative looks at the description of the texture, the taste of a particular food, or the narratives of what is told in experiences of people at work, the themes and patterns, etc. Now, we should also subdivide these into what we call discrete data and continuous data. Discrete and continuous. So under quantitative, we can subdivide our information into two categories as discrete and continuous data. What is discrete data and what is continuous data of quantitative research or quantitative data? So when we're dealing with discrete, basically, we are looking at data that has the following nature. It is distinct, the values are countable, they represent whole numbers or categories, they have no intermediate values, like the number of students that are attending this class, the number of cars that are in a parking lot, the number of emails you receive in a day. These are whole numbers. This is under quantitative. Quantitative has two aspects. Then there's also quantitative, which has continuous, and this continuous data represents measurements that can take any value within a range. It can have a finite number can be measured with great precision. So continuous data usually takes any value within a range. For instance, a height of individual 1.7 meters, okay, temperature 30.25 degrees, the weight of an object, and time is in a continuous or in a continuum. So data can also, under qualitative, be what we call nominal and ordinal. Nominal and ordinal. So what is nominal data and what is ordinal data? So when we're dealing with nominal data, just like we defined our data, which is continuous, and data which is discrete, under qualitative, we have measures of nominal data. Although that use SPSS, this will be very important. So nominal data represents categories or labels that are without any specific order or ranking. So these are distinct. They don't have intersections. For instance, you have red, blue types of fruits. This should be an apple, it can be an apple, orange. You have male, female, okay? So they're distinct. They're like discrete values. Then we also have ordinal data, which on the other hand has categories. It has intervals. It's not uniform. Okay, for instance, we can say educational levels, high school, college, postgraduate can have all income, socioeconomic income, low, middle. You can use a Likert scale, for instance, to measure such data. Strongly agree. You are agreeing, but to what degree you are agreeing? Or your race, you are both Tonga and Bemba. So it has intersecting shades of each. All right. So let's do a quick can you remember at this point. So I need you to tell me whether it's nominal, whether it's quantitative or qualitative, whether it's it is ordinal, nominal, or qualitative. Okay. So the height of an individual, can somebody tell me what category it is?
It's continuous.
It's quantitative, continuous, correct. About the number of times Zambia appears at the AFCON. Please, quickly.
Quantitative discrete.
Okay. Favorite color that one individual may have. Favorite color, what is that, quantitative or qualitative?
It's qualitative.
Qualitative, correct.
Nominal qualitative.
Nominal qualitative. How many siblings you have?
Quantitative.
Quantitative.
Quantitative what? Quantitative,
Discrete.
yeah. The rate of the satisfaction from 1 to 10. Rating your satisfaction from 1 to 10. What kind of data is this?
Quantitative.
Are you sure?
I also think it's quantitative, continuous.
Measure satisfaction. What instrument do you use to measure that? It's a Likert scale. So this is qualitative, ordinal. Capital city of France. What's the capital city of France? What information is this?
It's nominal.
It's qualitative nominal, correct. The number of hours you sleep per night.
Qualitative.
Wow. I beg your pardon?
Qualitative.
Is she right? Qualitative. So this looks easy, but you need to get the gist. So this number of hours, you can measure time. It's quantitative, but this is a continuum. So quantitative, continuous. All right, I hope you're getting the gist. The type of fruit in a basket. Okay, so I guess you get the idea of what I'm trying to bring across, okay? Can we proceed on identifying what type of data this is? Are we all clear? So these pieces of information can be presented by different types of pictograms. We have a pie chart, which looks like this. We have a bar graph, which looks like this. This is called a bar chart. We have a histogram, which is in continuum. So you need to know what type of data you use depending on. We have cumulative frequency graph, always accumulates. We have a relative frequency graph, which is fluctuating. We have a stem and leaf diagram. We have box and whisker plot. Looks like that. So these are pictograms that are important in our study, and you need to identify how and when each of these ones are supposed to be used. So I'm going to start with what we call ungrouped data. So we have ungrouped data that has 1, 2, 3, 4, 5, 6, 7. Okay, so that we have 4, 3, 5, 5, 3, 1, and 20. So whenever I given data, which is like this, the first thing you need to do is to rearrange it in order. So how do we rearrange the data in order? Starting with the smallest. So what data do we have there? Smallest piece of data.
1,
1, then
3,
3,
Another 3.
Another 3.
4.
4, 5, and 20. 5, 5, and 20.
So our n, how many are they? How many observations are there? 1, 2, 3, 4, 5, 6, 7. So we have 7. All right. So we're going to identify 20 measures of important measures. So we'll start with the range. The range is simply the difference between the highest number and the smallest number. So we use the formula maximum value of x minus minimum value of x. So here, our biggest number here is 20, and our smallest number here is 1. So our range, therefore, is equal to 19. And we also can find our mid-range, which is the opposite. We add the 2, the maximum value of x, plus the minimum value of x, divided by 2. So 20 plus 1 over 2, 10.5. Then we can also calculate our mode. The mode is simply the most frequent. Which number appears the most frequent in this case? We have 3 and what? And 5.
And 5.
It's got a bimodal frequency. All right. So this is as easy as it gets. Now, these are the values of x. Then you can square them to get the values of x squared. So these, you can square the values there. So 1 squared is 1. 3 squared is what? 9.
9.
9. Here we have 16,
16.
25,
25.
25. And 20 squared is what?
400.
Good. So when you add up the values of x on top there, we get the summation of what? X. So 1 plus 3 plus 3 again plus 4 plus 5 plus 5 plus 20. We're going to get our summation of x, which is 41. So summation of x is equal to 41. Then we're going to add 1 plus 9 plus 9 plus 16 plus 25 plus 25 up to 400. The value is called the summation of what? X squared. So this one will give us a total of 485. And our sample size n is equal to 7. So we're just tabulating the data as it is. So we can find our mean. The mean is also called the average. The symbol is x bar. So this one is simply found by the summation of x over n. So our summation of x is 41 divided by our n, which is 7. So what becomes our mean? 1 over 7, we're getting 5.857. So this is called our average. So you round up to the nearest 3 decimal places. Okay, so far, any questions? Are we together? Are we all following? Are we all following?
Yes, we are.
Then we can also find what we call the variance. The symbol for the variance of a sample is S squared. So this one is given by this seemingly long formula. Summation of x squared. So this is a bigger value, 485. Then summation of x to the power 2 which is 41 to the power 2. So 485 minus 41 squared over n, our n was 7, and everything over 7 minus 1. So you start from here. So 41 squared divided by 7 will give you 240. 142. So 485 minus the top 240, we're going to get 244.857. So you divide it by 7 minus 1, which is 6. So our variance, therefore, is going to be 40.81. All together, I repeat, our summation of x squared was what? 485. Our summation of x was what? 41. And our n was what? 7. So where there is this figure, this x squared, you put 485. Now these two are different. I don't know why students get to, again, put the same figure. This is summation of x to the power 2. So 41 to the power 2 over 7. Everything over 7 minus 1. So this is 240, you subtract from this figure there. Do it grade 1 way, step by step. 7 minus 1, 6. When you divide that, you get 40.81. That is called our variance. Our standard deviation is when you square root the variance. The square root of 40.81. In this case, therefore, square root that one, we're going to get 6.388. Any questions so far? Anyone behind at this point? Are you good? Okay.
Yes.
Then we get to what we call coefficient of variation, which is simply given by the standard deviation over the mean. So standard deviation is what? 6 point multiplied by 100. So this is 6.388. Over the mean we had calculated, the mean was what? 5.857. 5.857. So 6.388 divided by 5.857. So this will give us 1.09066 in percentage. This is 109.066%. But this is the coefficient of variation. It measures the degree by which we are deviating from the mean. Okay. Now we go to finding our quartiles. We have the first quartile, the second quartile, the third quartile, and the fourth quartile. First, second, and third quartile. So we use a formula which is simply a quartile is a quarter. So we have quartile number 1, which is a quarter of n. Quartile number 2 is half of n. Then quartile number 3, which is 3/4 of n. Depending on the book you're using, some of the books will tell you a quarter of n plus 1, half of n plus 1, and 3/4 of n plus 1. So you need to abide by the rules that are within. So this one is easy to follow. So the rule here is simply that if you get a whole number like 2, You pick the second number and the third number, you average them, you divide them by 2. But if you got a 2.1, you round up, which is 3. Even if you got 2.9, you round up to get a 3. If you get a 4, what does it mean? The fourth number plus what? Fifth number divided by what? By 2. That's the only rule. So let's find the quarters for this distribution here. Our n is 7. So what is the first quarter? A quarter of 7. What is a quarter of 7? 1.75. So what are we going to do now that we found 1.75? Mwinga, what do we do? We round up. Okay, to the second value. Even if it was 1.1, as long as there's a decimal point at the end, you round up. But if it was 1 exactly, you get now 1 in the second number. Okay, who wants to try the second quarter? So the second value here, therefore, is got what? This is value number 1, 2, 3, 4, 5, 6, 7. I mean, the second value in this case is 3. So the first quarter is 3. Okay, the second quarter, what's the formula for second quarter? Half of what? N. N is 7. So here we found 3.5. Can somebody tell me 3.5, what do we do?
You round up, which is going to be 4.
Okay, which is going to 4. Good. So which one is our fourth number?
4.
I spent that it is 4. Good. So the second quarter is also called the what? The median. So our median is 4. And lastly, our third quarter, 3/4 of what? N. So what is 3/4 of 7?
5.25.
So what do we do with 5.25?
You round up, it's going to be 6.
The 6/6. Which one is our 6/6 value?
5.
5. Good. So our Q3 is 5. All right. Then let's summarize our data. We have Q1, Q2.
So sorry to take you back.
Uh-huh.
What did you say you do if you find the whole number? You just take it as it is?
Okay, there's a question there. What do you do when you find the whole number? Suppose our
Yes,
answer
you take it.
was 4. What do? You get the fourth number and the fifth number. Divide that. It's a whole number. Don't take it as it is. You get the fourth number and the next
You
number.
take it as it is.
No.
Collins, why don't you take it?
Because the rule we're using here is n, unless it was n plus 1. So if it's the 4, exactly, you get the fourth number and the fifth number and divide by what?
2.
2, yes. Remember I said different books will give you their assumptions underlying the same formula. All right, so Q1, Q2, and Q3. Q1 was what? 3. Q2 was 4. Q3 was 5. So 3, 4, 5. So 3, 4, 5. And the minimum value of x was what? 1. And the maximum value of x was what? 20. Then we draw what is called a box and whisker plot. But before we do that, there's what we call the interquartile range. Interquartile range is the difference between the highest quartile, which is Q3, and the lowest quartile, which is Q1. So our highest quartile was 5, and our lowest quartile was what? 3. So what is the answer we get?
2.
So to code our interquartile range. We've got our interquartile range. And we can also calculate the lower extreme values and the higher extreme values by the lower extreme value is Q1 minus 1.5 IQR. The upper extreme value is the Q3. We add 1.5 IQR. The 1.5 is standard. So in short, to the lower value, firstly, multiply 1.5 times the interquartile range. So here our lower value was 3. Then the interquartile range was what? 2. So we multiply 2 times 1.5. So here it will be 3 minus 3, which is equal to 0. Then for the upper value, we start with third quartile. Our third quartile was what? 5. So we're doing plus, so we're doing minus, do plus there. So 1.5, in this case, 1.5 you multiply it by the interquartile range, which was 2. So you're going to have what? 5 plus what? 3, which is equal to 8. So this one, it wants to give us a range of values between 0 and 8. Anything outside that range is called an outlier. Anything outside that range is called an outlier. So our values were starting from what? 1, 3, 3, 4, 5, 20. So which one is outside that range between 0 and 8? Which figures are outside that range between 0 and 8?
20.
20. So 20 is called an outlier. So we illustrate the outlier using what we call a box whisker plot. So a box whisker plot has 5 key things: the lowest value of x, quartile 1, quartile 2, quartile 3, and the maximum value of x. So here we have what? The lowest value was 1, the first quartile was 3, the second quartile was 4, third quartile was 5, and the maximum value was what? Was 20. This is our initial diagram. But because 20 is outside the box of this one here, so our highest value in this case between 0 and 8. What is the highest value here now between 0 and 8? It is 5. So we're going to redraw our box whisker plot as follows. We have 1, 3, 4, and 5. So this is where the other thing will also end.